Mastering sampling techniques. Cluster sampling uncovers hidden trends that transform operations. How does the application of cluster sampling in operational excellence serve to facilitate the collection of data that is representative of a larger population, thereby enabling the identification of trends and patterns that can inform process improvements and drive operational efficiency? The application of cluster sampling in operational excellence plays a crucial role in facilitating the collection of data that is representative of a larger population, thereby enabling the identification of trends and patterns that can inform process improvements and drive operational efficiency. This is achieved through the careful selection of smaller groups or clusters within the larger population, which are then used to infer characteristics about the entire population. In cluster sampling, the population is divided into smaller, more manageable groups or clusters, based on characteristics such as geographic location, department, or product line. A random sample of clusters is then selected, and data is collected from each cluster. This approach is advantageous in operational excellence initiatives, as it allows for the collection of data from a smaller, more targeted group, rather than the entire population, which can be time-consuming and costly. One of the primary benefits of cluster sampling is its ability to increase the accuracy of data collection. By selecting a random sample of clusters, rather than individual units or data points, the risk of bias is reduced, and the results are more likely to be representative of the larger population. This is particularly important in operational excellence initiatives, where data must be reliable and trustworthy in order to inform process improvements and drive operational efficiency. Cluster sampling also enables the collection of more detailed and nuanced data, which can provide insights into specific trends and patterns that may not be apparent through other sampling techniques. For example, in a manufacturing setting, cluster sampling may be used to collect data from different production lines or shifts, in order to identify areas of inefficiency or quality control issues. By analyzing the data from each cluster, operational excellence practitioners can identify specific trends and patterns, and develop targeted strategies to address them. Furthermore, cluster sampling can be used to facilitate the collection of data from multiple sources, including both quantitative and qualitative data. For example, in a customer service setting, cluster sampling may be used to collect data from different regions or customer segments, in order to identify trends and patterns in customer satisfaction or feedback. This data can then be used to inform process improvements, such as changes to training programs or customer interaction strategies. In addition, cluster sampling can be used to facilitate the collection of data over time, enabling the identification of trends and patterns that may not be apparent through single-point data collection. This is particularly important in operational excellence initiatives, where the goal is often to identify and address areas of inefficiency or waste over time. Another key benefit of cluster sampling is its ability to reduce the cost and complexity of data collection. By collecting data from a smaller, more targeted group, operational excellence practitioners can reduce the resources required to collect and analyze the data, and focus on the most critical areas of improvement. This can be particularly important in resource-constrained environments, where the cost of data collection and analysis may be a significant barrier to operational excellence initiatives. Finally, cluster sampling can be used to facilitate collaboration and knowledge sharing across different departments or teams. By collecting data from different clusters, operational excellence practitioners can identify areas of best practice, and share knowledge and expertise across the organization. This can help to drive operational efficiency and improvement, by identifying and addressing areas of inefficiency or waste. In conclusion, the application of cluster sampling in operational excellence serves to facilitate the collection of data that is representative of a larger population, thereby enabling the identification of trends and patterns that can inform process improvements and drive operational efficiency. By reducing the risk of bias, increasing the accuracy of data collection, and facilitating the collection of detailed and nuanced data, Cluster sampling is a powerful tool for operational excellence practitioners seeking to identify and address areas of inefficiency or waste, and drive operational improvement and excellence.